going to talk about more trig formulas. But first, I want to say a couple things. I'm going to, at the suggestion of one of your fellow students, and because I decided it was a good idea, for the final, I'm going to provide you a cheat sheet. I'm going to put a bunch of formulas, a bunch of identities, most of the stuff we've done on a sheet that you'll have. And I'll post that as soon as it's ready, hopefully over the break, so that you can see what'll be on it, and you don't have to feel like you have to memorize, because not everything we've done really bears memorizing. You just know it's there and be able to look it up. Likewise, I'm going to try and put together a kind of a practice exam, just something you could try and get a feel for whether you know how to do stuff that might be on the exam. It's tricky. It's not going to be the exam, but with different problems. But I'll figure out what to do. Well, last thing I want to say, at the end of class, time allowing, and if you will, I have a short little 5-minute video, and it's on the practical use of trigonometry in the real world. And watching it, it makes me realize that what we're doing here seems very disembodied. I mean, you know, you might be in this class because you're going to take calculus, and so you think you need trig for calculus, or you might just feel it's just a requirement. And, you know, there's a great scene in this movie. I forget the name of the movie, but anyway, the actress goes back in time, fully grown, and she's in high school, and she's sitting in her algebra class, and she's already grown up, but she's somehow back in time. And she gets up in her algebra class and says, "I'm never going to use any of this in my life." And she walks out. And I understand how some of this stuff might feel that way. But then I saw this video and I was thinking, wow, at least a lot of the understanding of the physical world we live in, has to do with mathematics. So, okay, so I better get going because otherwise we won't have time to see it. All right, I'm going to start off where we left off, just to show an example of something you could do with one of the formulas we came up with. We saw that the sine of 2x, the double angle formula, is 2 sine x cosine of x. And I just want to point out that we can build on this quite a bit. For example, if I wanted to know a formula for the sine of 3x, well, you don't have to be all that creative to realize that the sine of 3x is the sine of x plus 2x, to which we can apply our formula. So that's 2 sine x cosine 2x, sine x plus sine 2x cosine 2x, cosine x, okay? And then we just have to apply the formulas we have for these again. Sine x, well, I think I'd like to get everything in terms of sines, so I think what I'll do is No, I won't do that, even though it is what I want to do. I'm going to start off with this as being 2 cosine squared x minus 1 plus sine of 2x, that's 2 sine x cosine x times cosine x. Of course, it is cosine squared. I already have what I want, but I can make it a little nicer. So I have 2 sine x cosine squared x minus sine x plus 2 sine x cosine squared x. I want to take out the sine, and I have 2 cosine squared x minus 2 plus 2 cosine squared x. Here I've already made a mistake. Maybe not. Sine x, 4 cosine squared x minus 2. Oh, but what's 4 cosine squared x in terms of the sine? I can use that, I can use the fact that cosine squared x equals 1 minus sine squared x. So I'll have sine of x times 4 times 1 minus sine squared x minus 2. I'm going to stop now, because now it's all in sines. I make it look a little nicer. All right, so again, I can do that with sine of 3x. I can do sine of 4x now. I can do the same thing with cosine. So I can build up some formulas if I need them. You can do this already too. You can do this with the sine, the cosine, and the tangent, because we have double angle formulas for them too. So that's one thing you can do with this. All right. There are some more formulas that we want to look at. In particular, the half-angle formulas. Okay, so how are we going to think about those? Well, let's start off with a double angle formula, cosine of 2x, and we're going to put it in this form: 2 cosine squared x minus 1. Now, the idea is we start with an x, plug in an x, and we can get cosine of 2x going this way. But if you think about it, we can start the other direction too, right? We can plug in an x here. We could plug in half an x, and we could come out with, well, something that looks like this. I didn't say that well, so I think I'll just demonstrate. Let's solve for cosine of x. All right, so we have 2 cosine squared x equals cosine of 2x plus 1. Cosine squared x equals cosine 2x plus 1 over 2. And let's find the square root, but let's be careful about it. We don't really know if this is plus or minus. All right, well, this is not a half-angle formula yet, but if I replace x with half of x, what do I get? Cosine of x over 2 is plus or minus the square root of, oh, now this becomes cosine of x. So that's my first double angle formula, half angle formula. Now you might say this is not a function, right? I'm getting two values out of it. How would I know which value to pick? Well, I'm going to have to look at this. I'm going to have to look at what my x is and decide based on which quadrant it's in. So, for example, if I wanted to find out the, say, the cosine of 80 degrees, I'm sorry. I wanted to find the cosine of 80 degrees over 2. Well, that's 40 degrees. And I know that 40 degrees is in the first quadrant, so I know it's going to be the plus. If, on the other hand, I wanted, say, the cosine of, let me pick the right number here, say 340 degrees over 2. Did I do that? Oh, cosine. Sorry. Say 200 degrees over 2. Well, this is the cosine of 100. Which quadrant is the cosine of 100 in? Which quadrant is 100 degrees in? 2, yeah. So what's the cosine in the second quadrant? Positive or negative? It's negative. So in that case, I have to choose the negative. All right, so even though this is a little confusing, it just means when you use this formula, you have to do a little work to find out what the SIGN sign is. Okay, that worked pretty well. Surprisingly, to get the next formula, we're going to start in the same place. Cosine of 2x, well, we saw it's 2 cosine squared x minus 1, but it's also 1 minus 2 sine squared x. So we can solve for sine of x here. How would we do that? You know, I do this all the time, and I realize some people will follow this and some people won't. I'll just say this, but I'm going to draw arrows. I'm going to switch these two. I'm going to add 2 sine squared x to both sides, so it'll come over here. And I'm going to subtract cosine of 2x, so it'll come over here. And we get the same kind of formula out of this. Okay, so now we have, now what do I have to do here? I have to just substitute x over 2. And now I have my half angle formula for the sine of x. Let's just do an example with that before we go on. Let's think about what would the sine of 15 degrees be? I think we figured that out using the difference formula in a different way. But so, of course, I want the sine of something I want to find this out exactly. Obviously, you can use your calculator and get an approximation. This is 30 degrees over 2. So my formula says this is plus or minus the square root of 1 minus the cosine of 30 degrees over 2. 15, obviously, that's in the first quadrant, so I don't really have to worry about the minus. What's the cosine of 30 degrees? Can you recall? Yes?
Root 3 over 2.
Root 3 over 2. All right. We could make this look a little nicer. It would be, what? 1/2 minus square root of 3 over 4, or square root of 2 minus square root of 3 over 2. It's still not very pretty, but it's an exact value. I'm totally going rogue here. We used to do problems like this. That's x, so I square it. 2 minus square root of 3 over 2 equals, I don't know, I'm just wondering if I can make that prettier. Right, so this is 1 minus square root of 3 over 2 equals x squared. So again, I want to switch x squared. 1 minus x squared equals square root of 3 over 2. I want to switch these two. And now I want to square this just to see if I can eliminate that. I don't think I can. 1 minus x squared equals 3 over 4. Yeah, this doesn't look very promising. Well, I mean, I could make this a, oh, what the heck. So this is x to the 4th minus 2x squared plus 1 equals 3/4. So x to the 4th minus 2x squared plus 1/4 equals 0. And this is a disguised quadratic, so this is 2. I think I'm just going to go back where I came from. Yeah. Oh well. There it is. It's ugly, but it's exact. All right. I'll leave it at that. Okay. We're not quite done with half-angle formulas, of course. We left out one of our functions. I'd like to know what the tangent x over 2 is. But as is often the case when you're looking at a tangent, if you recall that it's the sine over the cosine, you can move forward. Okay. So the sine is the square root of 1 minus cosine of x over 2, plus or minus here 2. By this I don't mean that these are in sync either, because then we know it would be positive. It just means we don't know what it is. 1 plus cosine of x over 2. So we can eliminate the denominators here, minus cosine of x over 1 plus cosine of x. Still have plus or minus. It turns out this is one form of We can do a little more with this. What could we do? Well, we could try that trick where we try and get this out of the denominator. I don't know if you recall that. We multiply this by 1 minus cosine of x over 1 minus cosine of x. That's, of course, 1. What do we get? On the bottom, we have 1 minus cosine squared x. And on the top, we have 1 minus cosine x squared. But of course, the bottom is what? 1 minus cosine squared is
Sine squared?
sine squared. So this becomes sine squared over 1 minus cosine squared. Well, what are we left with then? 1 minus cosine of x, sine of x. We could check that this is always going to be positive in all 4 quadrants. So this is just 1 minus cosine of x over sine of x. There's one more thing we can do with this. I think this was a homework problem. We wanted to verify that this equals sine of x over 1 plus cosine of x. What do we get from here to here? Any thoughts on that? I think this is one of those problems you just have to have seen it done once to figure it out. We could start on either side, but let's start on this side and try and get 1 plus cosine of x out of the denominator. Let's multiply this by 1 minus cosine of x, 1 minus cosine of x. So we have sine of x times 1 minus cosine of x over 1 minus cosine squared x. But this again, of course, is sine squared x over sine x times 1 minus cosine of x. And I can just eliminate one of the sine of x here, and I get 1 minus cosine of x over sine of x. So that's the one other form of this, sometimes useful. So those are, yes?
Did you, so 1 minus cosine x over sine of x equals sine of x over 1 plus cosine x. And the bottom ones, you foiled them? The bottom 2 ones?
I didn't foil anything, no.
I mean, not foil it, like...
Oh, this?
Yeah,
oh,
yeah.
well, yeah, I guess you could say
Reverse
foil that.
Yeah.
I used the a plus b
Yeah.
times a minus b. See how often that comes up? Wait until calculus. Yeah. Okay. And both of them are the half angle formula for the tangent. All right. Yes.
I get the rest of the part, but how did you go from 1 minus cosine of x over sine x to sine?
Right, I'm sorry.
Going
How do I get from here to here?
No, the 1 minus cosine of x over sine x to your left. To your left up.
To here?
No, of the actual 1 minus cosine x over sine x to the left. Oh, is it? Yeah. You go from there to there. Yeah, that's
From here to here?
Did you just?
Well, I didn't. I just stated that. I said, this is the case, right? Let's verify it, right? So I verified it by first just working on this side. I multiply it by 1 minus cosine over 1 minus cosine, which is 1. Simplify it, and I get this. I didn't do that in an orthodox order. Instead of going from A to B, I just said, I think A is equal to B, and now let me show you why. Does that help?
Kind of weird.
We do that a lot in the problems. They'll say verify this identity, and that's what they're asking you for. In other words, they'll say, we think this is equal to this, show how it is. I could do it the other way if it would make it clearer. Why not?
So did I feel like you would go from there if you didn't do it that way? You kind of guess like start with the conjugate the same way.
I mean, you know, there's this game you can play in math when you're teaching it. You can start someplace and then just go somewhere. Aha! We went on this journey. But then that can be a nice surprise. But along the way, the students don't know where you're going. Or you can say, this is where we're going to go, and then they at least have some idea. So let's do it. All right. So I'm just going to take this and I'm going to multiply it by 1 plus cosine of x over 1 plus cosine of x. Okay, on the top, I get 1 minus cosine squared x. On the bottom, I get sine of x times 1 plus cosine of x. Well, this becomes sine squared x over sine of x, 1 plus cosine of x. And then I remove the sign. So I have sine of x over 1 plus cosine of x. Is that better? Okay. All right. There's one more set of formulas. Oh, shouldn't have done that. Get them in here. These are the product and sum formulas. In a way, there's not much new here because we're gonna pick these right out of what we've done so far. But the idea is we'd like something of the form sine of x, cosine of x, and we'd like to express that instead of as a product, as a sum. So the way we do that is, the way we get here is we're going to start with sine of x plus, I'm sorry, it should be sine x cosine y. start with sine of x plus y, and we're going to add to it sine of x minus y. Okay, we know how to expand these. This is sine x cosine y plus cosine x sine y. And we know how to expand this. This is sine x cosine y minus cosine x sine y. These two terms drop out, and these two terms are equal. So this is just 2 sine of x cosine y. That's almost what I want. Let's just take, these two are equal, so let's just divide by 2, and we get our result. Okay, so that's the first of these product to sum formulas. So again, instead of having a product here, we just have this sum divided by 2. To get a similar result, we could instead take the difference of these two. So again, we get sine x cosine y plus cosine x sine y. And now we're going to subtract sine x cosine y minus cosine x sine y. We distribute this minus plus. So now these two terms drop out, and we're left with 2 cosine x sine y equals this. Sine x plus y minus y. And so I get, instead of sine x cosine y, I have cosine x sine y equals sine of x plus y minus sine of x minus y over 2. So that's 2 of my product to sum formulas. You might guess at this point I'm going to come up with the other 2 by starting with, instead of the sines, sine of x plus y and x minus y. Cosine of x plus y plus cosine of x minus y. Let's try this again. This is cosine squared x minus sine squared x plus cosine squared. Is this what I want? I don't want to get too far ahead of myself. Yeah, this is what I want. Plus sine squared y. No. Let's give me y. No, I'm completely brain dead today. Anyone? No. All right. This is cosine x, cosine y, minus sine x, sine y. That's this part. Plus cosine x, sine y, plus I don't know. I think my head is already on vacation.
Same.
I can do this right if I just shut up and think. All right. These two components drop out. 2 cosine x cosine y is equal to this. So cosine x cosine y equals cosine x plus y plus cosine x minus y over 2. And we just have one more of these to get through. If I change this to a minus, then I have to subtract this. But if I now distribute my minus sign, you see that now it's the cosines that drop out, and I get minus 2 sine x cosine y. Again, I have to just shut up here. Sine y equals cosine x plus y minus cosine x minus y. I'm going to divide by minus 2, so I'll get that the sine of x sine y is equal to, I'm going to switch these to get rid of the minus, cosine x minus y minus cosine of x plus y over 2. All right, these are definitely in the category of useful to know, but in the real world you could always look them up, so on the final they'll be on the cheat sheet. So these are product to sum formulas. Yes?
So, just to clarify, the first two are the same problem, or is there something else?
Sorry, the first two
The
are,
first two are listed like the same problem or solution? Equation?
Because they look the same.
Yeah.
Well, they're not though. Because one, yeah.
sine x cosine y, cosine x sine y.
Yeah.
They're almost the
No,
same.
but
Let's, what happens if we take this and we switch x and y, right? So then we get cosine y sine of x. That is the same as this, right? So So that's equal to sine of x plus y, we just switched them, plus, now we have sine of y minus x, and I switch them. We're almost there. Oh, no, Juan, you're right. There's a mistake. Why did you just say there's a mistake? Because you're too polite. Okay, one of these is wrong. This happens in mathematics. You make mistakes. You catch them, you fix them. Oh, all right. Let's start over and find out where the mistake is. So I want to find out what sine x cosine y is. So let's try sine of x plus y plus sine of x minus y. Make sure we do this right. This is sine x cosine y plus cosine x sine y plus sine x cosine y minus cosine x sine y. These definitely cancel. So it's definitely sine x plus y plus sine x minus y over 2. Now, very carefully, let me try this again. So that's minus, that's plus. These two cancel. Cosine x sine y equals this over 2. Aha, a typo. Okay, is that better? Thank you. This is the part where I get, kind of, I'm supposed to get huffy. If you were all watching, you'd all know that there was a mistake. None of you will succeed except for one here in life. Just kidding. Okay, there's one more thing we can do with these. Just as we took the double angle formulas and pulled out half angle formulas, here we have product to sum formulas. We can use these to pull out a sum to product formula. And how we do this is probably one of the simpler things we can do. We're gonna change the variables around a little, right? What I'm gonna do, let's just take this first one here. I'm gonna set x equal to a plus b. Those are gonna be my new variables for the moment. Guess I better do this over here. And I'm going to set y equal to a minus b. And I'm going to point out the obvious, which is if I add these two together, I'll get 2a. And if I divide by 2, I'll see that a is equal to x plus y over 2. And similarly, I'll see that b is equal to x minus y over 2. and I'm going to plug them in here. So I have the sine of again, I'm off today. I want this to be 2. So A equals x plus y and B equals x minus y. Okay, much better. So again, I have sine of A plus B over 2 times cosine of A minus B over 2. That's just a substitution, right? And what does my formula say? That's just going to be sine of A plus sine of B over 2, or sine of A plus sine of B equals this mess here, sine of A plus B over 2 cosine of A minus B over 2 times 2. But of course, it would be kind of messy to use A's and B's. We're used to using X and Y's in these, so let me just rewrite this. Sine of X plus sine of Y is 2 sine of X plus Y over 2 cosine of X minus Y over 2. So let me write this over here. So this is now, takes a sum and expresses it as a product. Clearly, I can do this trick on all 4 of these, and I'm going to get 4 different sum to product rules. I'll get a sine minus sine, I'll get a cosine plus cosine, and a cosine minus cosine formula. So an obvious question is, so what? What could this stuff be useful for? Right? Let me write down the other formula I'm going to use here. Cosine x plus cosine y. That's going to come from here. Is equal to 2 cosine x plus y over 2 cosine x minus y over 2. And here's something looks kind of cool. You can do with this. What if I were to ask for something ask for a product version of this formula? I want to know what cosine of 3x plus cosine of 7x is as a product. Well, I'm just gonna plug that in here, and I'm gonna find this is 2 times the cosine of 3x plus 7x over 2, that's 5x, times the cosine of 3x minus 7x, it's minus 4x over 2, so that's minus 2x. Oh, that's it. Oh, well, cosine of minus 2x I can get rid of that minus, right? Because cosine is a,
Positive.
well,
Even.
even function. I can get rid of it because it's an even function. That's just the kind of things you can do with these formulas. I'm sure you're going to get some practice doing this, doing the homework. All right, how are we doing here? Good. Okay, for anybody who came in late, I'm going to show you a short, I think it's about 5-minute video. It has trigonometry and history and geography, and it's kind of just really cool. It's also got some mountaineering in it. And it's got that annoying background music, but I can't remove that. Nope, wrong one. Sorry. Oh, there it is. It is the right one.
They start with a
Try again.
In this program, we've developed two properties of sines and cosines that help us determine.
It's hard to kind of get a feel for this. Surveying in India started in the 1700s. That's not that long ago. Your experience is different than mine. I grew up and we had dial telephones that became touch telephones, and we had black and white TV that became color TV. You have these little computers you carry around with you, but technology has advanced at a really rapid pace, and you have to kind of look back to realize just a couple hundred years ago, they were out like with these surveyor things trying to map the world. Today you have these maps that really describe it in great detail, but it's kind of worth trying to get some appreciation for how different the world is, how quickly it's changing, and no doubt how quickly it's going to change in your lives too. So anyway, thank you. Have a good Thanksgiving. Have fun. Come back ready for the wind-up.